Hi everybody, and in this video I want to take you through an example of using a rational function scenario for discovering an estimate of instantaneous rate of change. So when it comes to rational functions, we have to be a little more wary because in rational functions oftentimes we'll have a denominator with a variable, and that could mean that there are certain values that would produce an undefined result. And when you have an undefined result, you can't obviously figure out the instantaneous rate of change. You need a defined function at a point if you want to draw a tangent to that point, to put it kind of in more sort of visual terms, I guess. But let's work through a couple examples. So what if I were to give you something like this? F of x is going to be a rational function, which we're going to define as x plus 3 over x minus 2. And I am interested in the instantaneous rate of change, so m sub I at x equals to, let's just go ahead and say 4, okay? So since we're being asked to find the instantaneous rate of change at a point, I would suggest that we will use the formula for the estimate of average instantaneous rate of change, which will equal to f of a plus h minus f of a all over h, and the approximate comes in because what we're going to say is h is equal to 0.001, okay? So we're going to have h being a small number, but we're approximating it to a small value. So the thing you got to be careful with a question like this is the actual substitution in of your function to this formula. So let's be very careful how we do that and make sure that we don't forget we're dealing with a rational function. Okay, so here's what we'll do. We'll say this is equal to 4 plus h, because remember we're doing a plus h and the value for x is 4, plus 3 over 4 plus h minus 2, that's f of a plus h, minus f of a, okay, and when you plug in 4 for x, what you get is 7 over 2, so minus 7 over 2, and all of that is going to be over h. Okay, so you can see that, oops, we got something else showing up on the screen there. You can see that there's quite a bit of stuff happening there, and we have to be very careful with our simplification process now. All right, well, we might as well just, do some simplifying while we can. So 4 plus 3 is 7, so we got 7 plus h over 2 plus h minus 7 over 2 all over h, okay? And what we'll do now is we will go ahead and try to combine our numerator to a single denominator. So we're going to have 2 times 2 plus h, and then we're going to cross multiply these, okay? So I know that that's a bit of a shortcut, but we're going to go with that shortcut for now. So 2 times 7 plus h minus 7 times 2 plus h. Okay, and all of that is over h. So you'll notice that it's beginning to look, quite complicated, but I think if you stick with it, you'll find that things get nice and simple in a bit here. So this is equal to 14 plus 2h minus 14 minus 7h. See what I'm doing? I'm just distributing over 4 plus 2h all over h. Okay, I'm going to move up the screen now. I think there's going to be some more work here that I need to delete. A note to whiteboard users, always remember to clear Canvas before you do any whiteboard work. Get rid of that too. Okay, so, and let's just move this over here and just complete that erase. So you can see what's going to happen now, folks, is that we're going to have a bit of simplification that's going to take place, okay? And so let's go ahead and do that simplification now. So I'm going to just move this back on down here. See if I can get that. Okay, so we're gonna go, okay, so just to remind you in case you got lost, this is our last step right there. Let's just go over to here, okay, and we'll move down the page a little. So look, things start canceling out here now. The 14 minus the 14 cancels out. On top, we got plus 2h, and then I believe that's a minus 7h. Yes, plus 2h minus 7h, okay? So we got 2h minus 7h, which of course is negative 5h, over 4 plus 2h, all over h. Now watch, here's where things get interesting. When you divide a fraction by like negative 5h over 4 plus 2h all divided by h, that's like divided by h over 1. So we're going to go ahead and times it by the reciprocal, which is 1 over h. And watch this. So we got negative 5h over 4 plus 2h times 1 over h. And this is significant because guess what? That means we can start canceling out some h's. Why is my... Okay, so look what I can do. My screen here, my computer's messing up. But if you take a moment, what you'll see is that we can cancel out the h and the 5h. Not the 5, but definitely we can cancel out the h. And, you know, unfortunately, let's see if my screen's working now. There we go. That cancels out. And so what we're going to be left with is we're going to be left with the following. Negative 5, that is a 5, I apologize, over 4 plus 2h, and then we substitute in 0.001 for h, and what we're going to be left with is basically negative 5 over 4.0002 or something, right? Like 2 times 0.001 is 0.0002 or 0.002. So we add that to 4 and we do negative 5 divided by that. What we get is, we get something very close to negative 1.25, but we're going to say equals approximately negative 1.249, okay? And that is our approximate instantaneous rate of change at the place where x is equal to the number 4. And so what I see, the process kind of stays very similar, right? But, you know, you got to be careful because now when you're dealing with a rational function, you're dealing with a scenario where perhaps, you know, you could be more likely to make a mistake in your calculation. But you know, one of the things we do is we don't substitute in 0.001 for h until the very end. And in calculus, I think you'd find pretty quickly that the answer to this question, the exact slope would be negative 1.25 or negative 5 over 4, but that's beside the point. We're still in advanced functions. So now let me just finish off this video by taking you through one more idea, because we take that same function, which is f of x, right, equals x plus 3 over x minus 2, and we want to evaluate m sub I at x equals, oh boy, at x equals, well, originally I said 4, but what if I said 2? What if I said find that instantaneous rate of change at the place where x equals 2? Well, see, now you might recognize that there's going to be a problem, right? And watch what happens. So we go ahead and we say m sub I is equal to approximately 2 plus h, right, plus 3 over 2 plus h minus 2, and then here's the big part, minus f of a. So minus 2 plus 3 over 2 minus 2 all over h. But look, 2 minus 2 is 0. This is undefined. And now you can't just say like, oh, I'll take all of this and minus undefined. You can't do that. The whole slope becomes undefined. And so under this circumstance, right away you would say the slope of the function x plus 3 over x minus 2 cannot be evaluated at x equals 2 because the function is undefined. And so this is kind of a scenario that you need to be aware of when it comes to these rational functions, that it could pop up that you get an undefined scenario. And of course, the reason that would be undefined is because there's a vertical asymptote at the place where x equals 2. Thanks for watching. I hope you found that helpful.